Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Everybody okay? Okay. Today, before we start our class, I have one announcement. This is regarding Wednesday. Now, Wednesday is a holiday. Is that right? Holiday. But even we have a holiday, we have to stay home. So, holiday, no holiday, nothing much difference. So what I plan to do, we will have the makeup class on Wednesday. Okay, so the makeup class, you remember I missed one class a few weeks before a year. So that class I have not covered yet. So what I will do, we'll have a makeup class this Wednesday. So I don't have to reset another time, which is Friday, Saturday, Sunday, so to make our life easier, we'll have the class Wednesday. So this Wednesday, we have the makeup class. All right? Makeup class. To cover the class, I canceled last time. Same time, okay? Same time, 2 p.m. Okay. Okay, boleh? Is that okay with you? If it is not okay, it should be okay. All right? Because we don't have any choice. Okay? Now, I will give you some questions for homework. Today, we're going to do 13.3. 13.3 is on definite integral. I will give you some questions on 13.3. Question there. 13.3. Let me see. 13.3. Oh no, 13.2. No. Today I'm not. I shouldn't say 13.3. It should be 13.2 first. Okay, so 13.2, okay, 13.3. After that. So 13.2, I would like you to do this question. 13.2 from number 2 up to number 9.
Sorry.
Let's do some of them. And then number berapa? 10 to number 13. To 9, 10 sampai buat.
Sir,
Yeah.
you didn't share the screen yet.
Oh, ya ke? Oh, sorry. Tak share screen lagi eh? Tapi voice kena dengar. Okay. So the makeup class is on Wednesday. This Wednesday. That to cover the class. And then on 13.2, 2 to 9, and then give you a few more. 11 to 15. Okay. And then application do number 54, 56. All right. Now, 13.2 is on definite integral. Definite integral. So it's an extension of 13.1. If we know 13.1, then 13.2 will be handled fairly easy lah, because 13.1 is a basic concept. Now, what is definite integral? If you remember, okay, Integration is what? You have a function y equal to f of x. Then the integral of the function is integral of f of x dx is equal to f of x plus c. Okay. Now that is integration as per 13.1. You call it indefinite integral. Now for definite integral, we are doing the integration over interval. So here we are going to integrate y equal to f of x over an interval. All right. Now, when you say interval, we look at the value of x, okay, from x1 equal to a, let's say x1 or a, to x2, say equal to b. So the interval is for different value of y, for different values of the x. And of course, you can find the value of the y, corresponding to x1, you got y1, corresponding to the x2, you got y2. But to get to do the definite integral, what you need is only the value of the x, right? So you call it integral over an interval from x1 equal to a or x2 equal to b. So we denote the interval by the following. Interval is x1, x2, or you can call it like the book a, b. So that is called interval. Now that interval is a closed interval. When you do the definite integration, we do it over closed interval. So the straight line bracket here, the notation for the bracket like this, it's closed interval. Okay. Now if you have a bracket, normal bracket like that, so this one open interval. So in other words, when you have a closed interval, the endpoints included. Open interval, the endpoints excluded. So close endpoints included. So the point, okay, the point or the values of the x, a, b are included in the interval. Okay, right. Question? So that is the interval, and you are going to integrate the function over that interval. So how do you do that? Okay, first we look at the notation. Now the notation is the following. When you do that, you will do the following. You will integrate. Okay, you call it definite integral. Definite integral. Let us denote by f. Let's say it's an f, or I can call it a. Okay, I will explain what you mean by a after this. That will be the integral of the function f of x dx. We are talking the interval, right? A to b. So you are integrating from point A to point B. So you write A at the bottom, B on the top, like this. And that is equal to, we do the regular integration. So the integral will be f of x plus c. And then we are going to integrate over a, b. Okay, a, b. So you write like that. And that will be equal to, so we are going to evaluate. Okay, we're going to evaluate the integral at b plus c minus the value of the integral, or you evaluate the integral at a. Okay, so how do you do the integration? We evaluate the value of the integral at b, okay, and then you integrate, or you evaluate the integral at a, take the difference. Okay, take the difference. And as you can see here, c and c we cancel out. So what you would have is f of b minus f of a. So the definite integral is basically what? It's basically we evaluate the integration, okay, f, capital F, at b, and then you evaluate the integral at a. That means the first point, the last point, initial point, end point. And then what do? We subtract. Okay, take the difference. That would be the definite integral of the function f of x over the interval a, b. Okay, and that is equal to a. That is equal to a, or you can call it capital F. Now, what is a? A is simply short form to the area. Okay, area under the function, under the curve. Sometimes you call it under the curve. From x1 equal to a to x2 equal to b. Sudah. So the definite integral, you will get a value. Okay, we call the value a. fb minus fa, we call it equal to a. And what is it? It's the area under the curve, under the function, from a to b. Okay, all right. Now, graphically, we can intuitively see it's something like this. You got the graph y, x. Suppose you have a function, something like this. Y equal to f of x. Okay, then you want to integrate, or you find the definite integral from a, this one is x1 lah, or x1, to endpoint b, x2. So that is interval a, b. So I want to find the integral over that interval. Okay, and the value of the interval, or the value of the integral, is the difference between fb and fa. And what is it? Is the area. Okay, is the area under the function between a to b, and that's the area. Okay, so that is definite integral. Okay, before we continue, any question, anything that you are not sure, or anything that you don't really get? Okay, anything?
Sir,
Yeah.
with the close bracket, we include not only the endpoint but also the initial point, right?
The end point and initial point, both. Did I say? Didn't I say initial point? It includes.
Yeah, you just mentioned the end point.
It includes both. Okay. The end point, which is b, and also the initial point a. All right. Include the initial point, the first point, initial point. Okay, a, and also the end point. Okay, end point. Okay. Not just the end point. It includes both. Okay. All right. Okay. Any other things? So that is definite integral. Okay. All right. Now let's do an example. So example number 1. Suppose I have a function y equal to f of x equal to 3x plus 5. I want to find the definite integral of the function over a, b equal to, say, 2, 6. So that is the interval from a to 6. Okay, all right. Now, it's always good that we sketch the graph of the curve so that we can visualize, okay, how the area that we are talking about. What is the area that we're talking about? Okay, we just need to sketch the graph. draw. Okay. All right. Now, if you look at this function here, a simple function, how does the line look like? 3x plus 5.
Straight line, sir.
Straight line. Okay. Straight line. What else? Straight line is not enough because straight line can be whatever. We need a okay straight line. How?
It is at the positive side,
Positive side. What do you mean by positive side?
above the line.
And it is horizontal, sir.
It is not horizontal. Okay. It is a
it is
straight line. It is not horizontal.
Why?
How does the curve look like? Is it going up? Is it going down? Or is it going? It's not horizontal. Okay. Is it going? How is it going?
Going up.
Going up. Why going up? Why going up? Cepat. Takkan dah lupa ni. Why is it going up?
Because the m is positive.
Because the slope is positive. Okay. So when you sketch this thing, okay, we know. You look at the slope first. All right. Is it negative or is it positive? Okay. Of course, this linear function is very easy. So you know it's positive, so it's going up. Now, what is the intercept? Where does it intercept the y-axis? The line will not go like this. Intercept at 5. So the curve will look something like that. The intercept must be at x equal to 5. So that is the 5 here. Okay. So when you sketch a graph, a function, a linear function should be kacang lah. Because linear function is the one is easiest to draw, to sketch. Okay. You just need the slope and you need the intercept. You know the line is straight. You just determine, is it going up or is it going down? All right. So you have the curve here, 3x plus 5. All right. And the interval that we are looking at, that we are talking about, is from 2 to 6. And we know that definite integral is we are looking at, or you want to determine that area here. Okay, the area A under the curve from A to 6. So we can use A. All right, A is equal to what? A is equal to the integral from 2 to 6 of the function 3x plus 5 dx. Okay, so what is it equal to? That is equal to, now we know that the c will cancel out, so you don't need the c anymore. Okay, so you got 3x squared over 2 plus 5x. So c is out. Okay, c you don't have to, for definite integral, that c you don't have to include, because we know at the end of the day the c will cancel out. So 2 to 6, and then we evaluate. Okay, we evaluate the integral at 6 and then subtract the value of the integral at 2. So we got 3 times 6, which is the end point, square over 2, okay, plus 5 times 2. So that is our first value. That is the value of the integral at 6. And then you have to subtract 3 over 2. Okay, I need to clear. Okay, 3 over 2. 2 squared plus 5, 2. Okay, here shouldn't be 5, 2. It should be 6. Okay, all right. So you get the value. Can you evaluate? Evaluate the integral at 6. What is the value? 3 over 2, 6 squared. 3 over 2 multiplied by 36. What do we get? And then plus 5 times 6, that is 30. So what is the value of the integral at 6? Can anybody Compute cepat. Quickly.
84.
Berapa? 85 eh?
84.
So here you got 84. Okay. Do the second one. Ini senang sikit. 10 campur 3 campur 6 eh. 10 campur 6, 16 eh. Is that right? 16? Betul tak?
Yes. Yes,
16. 84 minus 16, you got 14. 8. 8, 68. Betul tak?
Yeah.
So that is 68. So you get the value. Okay, you got the value, definite value. And that is the area under the curve. Okay, between 2 to 6. And the area is 68. Now, if you recall from your basic maths, if you are talking about area, what is the unit for area? Area, apa? Area, you know. And then unit dia apa? Unit dia apa? You got the width multiplied by the height, the length. Okay, so what is the unit?
Meter squared.
The unit is unit square. Okay, example, you got meter square or mile square. So the area is 68 unit square. But for us, you know, you don't have to write the unit. Okay, people do not write the unit. You just write 68. 68 the unit. But in fact, it is what? It is an area should be unit square. Okay, but normally we don't say it. We just say unit. Why unit? Because in application, when you find the area, suppose the unit of the area is dollars, you know, the unit of the $10 dollar. Okay, so you will get what? I will get dollar. So you don't call it dollar square, you know, you just got dollar. So sometimes, you know, for application for us, we don't say the unit as an area for unit. We just use the basic unit. All right. Okay. So that is definite integral. No, I give you another example. Okay, example number 2. Okay, example 2. Suppose we consider a function y equal to f of x equal to negative 5x squared plus 20. Right? And then I want to find the area under the curve, or you want to evaluate the definite integral from 1 to 4. Okay. Now, I want us to sketch the graph. Okay, this function here, quadratic function. How does the curve look like? Non-straight. Yeah, you know it's non-straight. So more detail. You know how does it look like?
It's concave up and down.
Concave lah. You know, you don't have to say concave. Just say how does it look like. If you say concave, you know, most of us do not understand concave because we are not talking about concavity. How does the curve look like in our term? You know. Macam mana?
Ke bawah, sir.
Ke bawah. What do you mean by ke bawah? Now, when you draw a quadratic function, you sketch. Okay, it's either the curve is going up, going down, or going down, going up. Okay, it's either the curve is going like this or the curve is going like that. That is quadratic. Now, for this one, which one is it? Is it going up and down, or is it going down up?
Up and down.
Up and down. Because you know, when you have a negative here, you have a maximum. Okay, so it's a maximum. So you recall back our second derivative test. Okay, so you need to know whether it is going up and down, or is it having a maximum, or is it having a minimum, and then what is the intercept? Intercept is 20. All right. So that is the only thing that we need when you want to sketch the curve. And the curve that we normally sketch would be either quadratic or linear. Okay. These are the simple curves that we are dealing with. We are not, I'm not asking us, we don't really sketch cubic functions to sketch. So you have the quadratic, will look something like this. This is x and y. The curve here at 20. So at 20, intercept here is 20. Okay, it's not the maximum. Okay, maximum is something else. Intercept at 20. So maximum there somewhere else. So maximum dia kat mana? To the left or right? That one we don't know. Okay, maximum dia kat mana? Is it to the left of 20 or to the right of 20? Ten x, 10x, 10. Maximum is at 20 je tak? Betul tak? Maximum dia kat 20. Because you take the y prime is negative 10x. Okay, so x equal to 0. So x is equal to 0, that's the critical point. So x equal to 0, y equal to 20. So that point je. Betul tak? Can you check? Maybe I may be wrong. Okay, so you got this. Now, we want to determine the area under the curve from x equal to 1 up to x equal to 4. So that is the area. Okay. So the integral that you want is a, which is integral from 1 to 4 of negative 5x squared plus 20 dx. Okay, I want you to finish it up. Okay, so finish it up now. I give you 5 minutes. You get the integral, evaluate the value, and then determine what is the definite integral. Okay, do it now. Okay, anybody got the value yet? What is the integral that you get? So, what is it? It's negative 5x cubed over 3 plus 20x. And then you evaluate the integral 1, 4. Okay, so you do the evaluation. I skip the step. Okay, now when you evaluate the integral at x equal to 4, what is the value? Anybody got it yet? Just share with us. Okay, the first person who get the value at 4, let me know. And then get the value at x equal to 1. All right, anybody get it? Hey, cepat sikit, weh. Okay, what is the value of the integral 4? Anybody?
I got negative 26.67.
Oh, yang ini. Is it negative?
Yeah.
Same,
Yes.
sir, same.
Hmm.
Yes, sir.
Ah, so in that sense, probably the curve that I sketch here, betul tak kan? Negative 5x squared plus 20. The maximum occur at 20. Okay, let's see. So negative apa tadi? Negative?
Negative 26.6.
Negative 26.6. You will take away, all right, take away. At 1, what is the value?
18.33.
18.33. So you have a negative value. Okay, so the value is negative. So value is negative. That means negative. If the value area negative, that means the area will be somewhere here. Okay, is the function not right? I do the maximum point. You got negative 5x squared plus 20. The maximum is 20. All right, the y-intercept is 20. And then the x-intercept. Okay, let's check the x-intercept. X-intercept when y equal to 0. When y equal to 0, you got, I think that's the problem. When y equal to 0, negative 5 x squared plus 20 equal to 0. So negative 5x squared equal to 20. And then you got x equal to 2. Patutlah. The maximum here, the intercept here is 2. Okay, intercept is 2. So when you got 4, that would already is negative. So our area actually the sum of that two parts. So negative here and that. So that's why you got a negative area. Okay. So negative area, actually, we don't deal with negative area. We want to do only positive area. So, but why you got negative? Because up to 4, that is already negative. All right. So I shouldn't do that. So negative exam area, okay lah. Tapi we are not really concerned about negative area. So what we will do, we modify. Okay, we modify the question a little bit because the x-intercept is actually 2, so it should be, should be from 0 to 2, or I make it from 1 to 2. Okay, so we change the interval. We use 1 to 2, or you can use 0 to 2. Okay, all right. You can do it at home. Okay, so that is homework question. The one that you got negative, why negative? Because at x equal to 4, the line is already on the negative side of the graph. Okay, so you got a negative value. Don't worry about that. Okay, don't worry about it. We don't need. We will not do anything negative. So modify. We do ni. Balik rumah cuba buat. Coba either propose interval lah. 1 to 0 to. Should be positive. Kalau negatif lagi, next class we'll talk about it. Okay, all right. Good. Okay, now application. I don't see any application here. The application that is given in 13.2, they use the E function. E function we have not done yet. So what I will do, we will discuss question. in 13.2, and that is on the application. So we're going to look at question number 53 on the application. So if you look at question number 53, it's about depreciation. So can you read that question number 53? A few minutes, and then we will discuss that question. At least, and then you know what you want to find and what we are given, so that we can solve that problem. Okay, spend a few minutes reading that question. Now, if you look at that question, what are we given? We are given the rate of depreciation. So the rate of depreciation is d prime. That is the derivative of d. Okay, derivative of d. When you integrate, what do I get? I get depreciation. So it's like antiderivative. You are given the derivative of the function, okay, f prime. So for what we learned earlier, okay, you are given the derivative f prime of x, we integrate, what I get will be f of x plus c. So you are given the rate of depreciation. You integrate, okay, we integrate that, you will get depreciation. So that is the question. You want to find what? You want to find the depreciation for a given interval, okay? And the time, okay, time, let's call it T, that is in years. And depreciation is what? Depreciation is in dollars, okay? Depreciation rate is given dollar per year. So D prime is given dollar per year. And depreciation. So you want to find depreciation. Now it's good that we sketch the graph so that we see what we are looking at. So if you do this, okay, you want to draw it d prime, okay, the function which is d prime, and then you draw it against t. Now you look at the function there. What kind of function do we have? The d prime. Okay, d prime is equal to what? You have here, 3,000 multiplied by something in the bracket. Now, what type of function do you have there?
Linear.
Linear function. Okay, so you got a linear function. You multiply out. What do we get? We get 60,000 minus 3,000 t. So that is a linear function. Now, how does it slope? Is it going downward or is it going upward?
Downward, sir.
It's downward sloping. Okay, it's negative slope. That means the line is going down. All right. What is the slope? The slope is negative 3,000. What is the d prime intercept?
60,000.
D prime, I got to make it larger there. The intercept here is 60,000. So somewhere there, 60. So we do the unit in thousands. So that is 60. And then the negative slope. So we can compute the t intercept. What is the t intercept? Anybody can find it? How many years the depreciation rate is equal to 0? Okay, what is the value here?
20.
20. All right, the line is straight line. We go like that. Okay, so that is d prime. So if you look at the graph at A, actually we want to find the graph. Okay, you have to sketch the graph, which we already did, from 0 to 20. All right, the t-intercept is 20. The depreciation rate will be 0 at 20 years. After that, the depreciation rate will be negative. So we don't deal with that. That's why they give us time from 0 to 20. Okay, 0 to 20. 20 interval 0 to 20. 20. Bukannya 0 to 20. So in other words, 0, 20. That is what is given. Okay. Now, what you want to find, okay, is not from 0 to 20. What you want to find is from 0 to where? 0 to 10. So 0 to 10, you mark the 10 over there, somewhere in the middle. So that is our area that you want to find. So for part A, you sketch the graph. You want to find the depreciation over 10 years. So that is the area. So you can call it D. All right, because integrate D prime, you got D. Basically, that is the area under the curve. And D is depreciation because it corresponds to the application. Okay, all right. So in order for us to find the D, it's equal to what? It's equal to the integral from 0 to 10 of, okay, of the function here. All right, from 0 to 10. So I want you to do it now, okay? Do, practice. Okay, fine. Evaluate the depreciation rate, okay? Get the value of the integral from 0 to 10. Okay, do it now. Finish it up. Okay, I'll give you 3 minutes. Okay, got it. So the integral from 0 to 10 of 60,000 minus 3,000 t dt. Okay, so that will be equal to 60,000 t minus 3,000 t squared over, and then evaluate it from 0 to 10. So here you cancel out, that becomes 1500. What is the value? So you do the integral at 10. What do you get? Okay, give me the value. So I write down, okay, I write down 60,000 times 10, okay, minus 15,000. Okay, wait, let me write down everything first. Then, okay, that is the value of the integral at 10 minus, even though it is 0, we still have to do it, okay? So that we know that we are evaluating the integral at 0. Of course, you know the answer will be 0. Okay, 15,000, 0 squared. Okay. So you know the second one will be 0. Now what is it equal to? Anybody? Berapa dapat?
It is equal to 450,000, sir.
450,000. Betul? 450,000 dollars lah. Okay. So the depreciation, the total depreciation for the first 10 years. So we say that the total depreciation, no, it's not the rate anymore, okay? Because we are integrating the rate. So it becomes the total depreciation over the first 10 years. Okay, the first 10 years is how much? Is dollars 450,000. Okay. So that is one application. I give you a few more questions. So I think, the idea is you are given the rate of change, right? You are given the derivative. So you find the function. Okay. Now there is actually one or two properties that I need to mention, which I didn't. So let's go back to 13.2. There are a few properties which are useful, which we can apply when we do this kind of thing. There are a few properties of a definite integral. Number one, if I have integration from A to B of a constant multiplied by some terms in x, we call f of x, then the constant will just follow the integral. So you can bring out k, integrate from A to B of the f of x. Sometimes, this thing that we normally don't do, okay? But actually, we can take out the constant so that we have a smaller number to deal with. Say, example, you have 150 x squared. Let's say you have y equal to 150 x squared, and then you want to integrate it, okay, over, say, 1, 5. So here, you want to find the integral from 1 to 5 of 150 x squared dx. So what you can do, you can bring out that constant. So that will be equal to 150, just integrate the x from 1 to 5. And that will be equal to what? That will be equal to 150. Now I do the integration. That is equal to 150. You just take out the 150. And then that will be the integral of x cubed over 3 from 1 to 5. So when you do the integration, when you evaluate the integral, you just leave out that 150 outside. Don't worry about that thing. You just worry about the evaluation of x cubed over 3. So that is one good thing about this property. The constant you put aside first. Okay, so that you will have a smaller number to deal with. If you have the constant, then you have to multiply the constant everywhere. So sometimes it may be tedious. So that is property number one. Now property number two, property number two is more useful. All right, we normally, you have this property sometimes make our work easier. So property number two is the following. Property number two, you have two functions, okay, two terms in x, and you are integrating over an interval. So let's say I have y equal to f of x, and then I have another function y equal to g of x. And then we are evaluating the interval from A to B. So we have the following. We have the following. So what do I have? I have the following. The integral from A to B of f of x dx plus the integral from a to b of g of x dx. And that is simply equal to the sum of the integral. That means I sum the function f of x dx, and then I integrate. That would make our life easier. So rather than you do integral of f of x, and then you do another integration, g of x, it's easier for us. You add them up first and then integrate. So here you do only one integration. So this is one good use of that property. Example, okay, I'll give you an example. Let's say you want to integrate from 3 to 10 of, say, 3x to the power of 3 minus 10x squared plus 5 dx. And then I have another function, x to the power of 4 minus 3x squared minus 4 dx. So here, you see the function, the power is quite high, 3 and 4. If you do it directly, that means you have to do one integration here, and then you have to do another one. That is a lot of work, okay? Now, if you apply that property, what do you have? You have the integral, you sum the function first. So you put them together. So I need to put another kind of bracket. So you got the first function. 3x cubed minus 10x squared plus 5. Okay, that's one. And then you add x to the power of 4 minus 3x. Ini cube nih, sorry, cube. 3x cube. I want to do a cube minus 4 dx. Okay. So if you look at here, if you do the addition before you integrate, then you will see that some of the terms you can simplify. Okay. For example, okay, 3x cubed, 3x cubed cancel out. Okay. And then the constant 5 minus 4, now you get 1 rather than 4 and 5. So that will be equal to the integral 3 to 10. So here you write 3, 3, 10. Bukannya A dengan B, 3, 10. Integral from 3 to 10 of what? Of x to the power of 4. The 3x cubed now is gone. So you got 10x squared plus 1. Nampak tu? Senang cerita kan? You have only 3 terms. So that is application of the rule. All right. Okay. So finish it up. Okay. Finish it up. Homework. Okay. You do it as homework. Complete the thing. So what I want you to do is this. I want you to evaluate integral number 1. Integrate, integrate 2. You sum it and equal to whatever. Okay. Now, next one is you add the thing. This is what you get. I want you to find what is the value here. And then you check whether what you get here is the same as the one that you get by adding the 2 integrals. Okay, so it's not just you do this one, okay? You have to do 1, 2, add them up. All right, and then you add them up, integrate, and see what you get. They must be equal. Okay, so that is to show by simplifying the addition, we are making our life easier. And that is actually help us a lot. Now, this rule is also true for subtraction. So it's just like sum and difference rule. So if you have a difference, that will also be, okay, so I put a bracket there. I put a bracket there. Both can be applied. Either you have a positive sign or you have a negative sign. So in short, if you look at the name earlier, it's the sum and difference. Okay. Any question? Anything? Okay, good. All right. Now, this is rule number 2. Very, very practical. Property number 3. Okay, property number 3 is the following. So here, okay, in short, you have two functions, same interval. Now, in property number 3, I have two intervals, one function. I have y equal to f of x, and then we want to integrate over two intervals, a, b, and then another interval, b, c. Okay? So the integral will be equal to what? The integral or the property of the integral will be the following: a, b, f of x dx plus, okay, the integral from b to c g of x dx. Okay, same function. I'm sorry. F of x dx, and that is equal to, you don't have to find two integration. So what you do, you integrate from a to c, okay, from a to c of the function. So you can do only one integral from the first point to the last point, okay, of the second interval. But if you look at the graph of this kind of thing, it should be like this, because we're talking about A, B, B, C. Okay, so macam ni, y equal to f of x. So I have A here, B here, C macam tu. Okay, you cannot have a gap. The interval must be the same B in the middle or in between. You cannot have a gap. Kalau ada gap, tak boleh lah. Okay, let's say I got that one, A, B, and then another interval here. Ini tak boleh. Okay, it must be like this because we are talking about A, B, B, C. All right. So you have this two area that you want to find. It's just the same as what? As finding the interval of f of x over the endpoints of the two intervals combined. So it's just the integral from A to C, okay, of that function. Okay, so this is property number 3. I'll give you an example. Ini 13.2 lagi tau. Just the property. So when you do the question that I give you though, you can apply this property if there are any lah. So here, let's say I want to find the integral from 5 to 8 of 2x plus 1 dx plus the integral 5 to 8 2x plus 1 dx. So how do you do it? That will be equal to 5, 8. Salah. It shouldn't be 5 to 8. Ini kena benda lain. This one should be what? Should be another interval. This one should be from, say, 8 to 15. Okay? So that will be equal to the integral from 5 to 15 of 2x plus 1 dx. Okay, all right. I want you to finish it up. So that is another homework question. Finish it up. So you do this, like what I did earlier. You integrate this one, you call it number 1. Integrate that one, call it number 2, and then you add. What is the value? After that, you do the sum first. Okay, you do the integration over the combined interval from the first point of the first interval to the last point of the second interval. That means you do this one, you get, see what answer that you get. So they should be equal. Okay? So just to show that property. When you do this question, this homework, this example, I want to do it as homework. Okay, all right. So that will be the end of 13.2. Now 13.2, we are finished. Well, I actually, we do some of the examples already. In fact, we did already application because I forgot that property. So that will be end of 13.2. Okay, any question, anything? Okay, good. Now, actually, you have only 3 more weeks left. Okay, so if you have the Wednesday class, then after that, we have 2 more weeks. So 2 more weeks, I think we have time to cover the matrices. So the matrix, we will not deal with, we will make matrices simpler than it should be. So what I mean is that if we don't have time, we only look at a simple matrix, a simpler matrix. So it'll be easier for us to deal with, given the time that you have. So now let's move on to 13.3. Okay, 13.3 is area between 2 curves. Okay, area between 2 curves. What we do now is that we are looking at the area only under 1 curve. So 13.3, we extend it further. We are looking at area between 2 curves. So this is the idea. The idea is the following. So 13.3, you have 2 functions, times 3 functions, y equal to f of x. And then I have another function, y equal to g of x. All right. Suppose you have the graph look something like this. So we draw the graph first so that we know how we look like. So let's say f of x look something like that. And then g of x so look something like this. Now, what you want to find is this area, A to B. And that is the area that you want to find. So that is what you call area between curves. Okay, area between curves. It's not area under 1 curve. It's area in between, the area that is the space. Okay, area the celah there. Okay. Now, how do you do that? So what you want is the area here. Okay, now, if you look at f of x, to function there, the area of f of x under f of x from A to B is the whole area here. Betul tak? The area under f of x is the whole area. Now you don't want this. Okay, I don't want that one. I want what? I want only that part, which is bordered by another function, g. So now, how do you do that? So if you draw it individually, okay, if I draw it individually, that's the area under f, the whole thing, okay? Area under f is the whole thing here. I put now in red, which is this one, okay? Now, what is the area under G? Area under G, kita sketch lah. Sketch balik, G itu. Okay, I reproduce the G, will be something like that. G itu, something like this. That means from here, and then you want the area from A to B. So the area under G of x from A to B is that area. The area ni. That one. Okay, you want only the area A, okay, which is between F and G. Now, if you look at the curves individually, the area under F is the whole area from under F, from the F up to the X axis, okay, up to X equal to 0. And then, no, from X equal to 0, Y equal to 0, the X axis. And then the area under G is the whole area under the curve G below it line until the X axis. So how do you get the area A? Okay, question is how you get the A. Okay, now you look at the graph, I draw the function. So tell me, how can you find the area A? Just tell me in terms of the area, okay? And then we can do the integration.
Minus.
You minus, okay? Minus what? What minus what?
Area F minus
Area A. What do you mean area A?
area F.
Area under F, okay? Area under F minus area under what?
Under G.
Under G, okay? So the area A is the difference between the area under F and the area under G over AB, because we're looking at the same interval. If you are looking at different interval, then there is nothing that we can do, okay? So the area A is the following. In terms of integration, the area A, okay. Now this is, if you look at the book, it's 13.1, 13.15. They give you 13.15, or the diagram. Oh no, the figure. So the area A is equal to the area under F. So area under F is the integral from A to B, F of X dx, minus the area under G, which is the integral from A to B of G of X dx. So you have to subtract area under F and the area, you have to subtract area under G from area under F. So I got that area. Okay. So we are making use, okay? We are making use of the function to determine what area you want to find. And of course, the area is between two curves. Okay, all right. So I will give you a few more examples. And sometimes it may not be just subtraction, it can be addition. So it's not just between, sometimes area over two functions, something like this. I will draw another graph. So let's say I want to find the area here. Let's say this is f of x, g over. All right. Suppose I want to find the area here. Call it area A. Okay. All right. How can you find the area A? Look at the graph. Tell me.
We minus gx minus fx.
So if the area under G, okay, because G is the one that is on the top, minus area under F.
Under f.
Under F. Now, that is area under the curve. Now, from where to where? The next thing is, you identify already the functions, okay? Functions already identified. Good. Second, what is the interval that we're talking about? From where to where?
From 0 until the intersection.
From 0 until the intersection. I'm sorry, not intercept, intersection. So I need to find that point. We call it B. Okay, so that point B is intersection, which we know. So in order to get the interval, the first point, you know, is 0. Okay, so the interval is from 0 to B. And the B, you need to find. Okay, we can find it because we already do this many times. Okay, intersection of F and X. You can set G of X equal to F of X. Then you get the equilibrium point. Okay, then you get X equal to B. And then, of course, you can find the value of Y, but you don't need that. You only need X equal to B. So what is the integral? The integral A, or the area A, is the integral from where to where? From 0 to B of G of X dx minus the integral from 0 to B of F of X dx. Okay, all right. Okay, next. Suppose I want to find this area here. The one that I shade in red. I call it the area here B. Okay, how can we find area B? Okay, you have to identify the functions, identify the interval. Okay, in order for you to do that, those are the things that we need. Okay, there is no more than that. That is exactly the two things that we need. Okay, now tell me.
So there are many ways to count it, right?
Tell me one way. Okay, if there are many ways, tell me one way. I don't need that many ways. I need only one way. Okay, how?
Area and the GX from 0 and the NTX intercept
Okay.
minus.
Okay, wait. Stop dulu. So the first thing is, if you look at the whole area B, okay, you can break out into two parts. Because if you look at the graph, it is from 0 to the point E is the area under F. Betul tak? And then from the intersect here to that point, the X intercept of G, it's another curve. All right, it's another area. So we are going to break down the area B into two parts. Like our friend was saying, is the area under G from 0 to the into the intersection. And we already know, okay, intersection is B. So that is the first area. All right. Now, what is the second area? Oh, Nur Farah. Okay, Nur Farah. Second area, mana satu? Nur Farah, are you here?
Yes, sir.
Apa dia? So second area tu area yang mana?
GX.
Area under G of X. Okay, from where to where?
B to X.
From B.
B to this one.
Benda ni ya. Okay, so you need to find that C. Okay, so there is one more thing that you need to find. Suppose we start over, all right? Actually, there are two things that you need to find. Number one, you need to find the intersection. You get B. Second, you need the X intercept. Okay, so you need the x-intercept of D. So that would be the things that you need to know or you need to determine in order for us to get intervals. Okay, and after that, we can get the area. All right, so for that thing, what you need, if I start from the beginning, that means we need the following. I need, number one, the point B, x equal to B. So that is the intersection F equal to D. Okay, that's number one. Number two, we need the x-intercept of G. So I don't think there is a problem. We call it x equal to C. Okay, so suppose x equal to C. So now I have the interval 0, B, C, and they are over different functions. So how do you get the integral? So you have to add, okay, the area under F from 0 to B plus the area under G from B to C. So the area B will be equal to the following. Be equal to the area from 0 to B, f of x dx, plus the area from B to C of g of x dx. So that's how you got area C. Okay, all right. Okay, one more. Suppose I want to find the following area. I want to find only that part. Call the area C. Okay, look at the graph. Look at the functions. Look at the interval. And see how I can find the area C. Okay, alright. Saya tak payah sebut nama lah. Nanti saya cari nama. Kalau tak ada orang cakap, saya akan cari somebody. Okay, sebab Nur Farah dah buat dah tadi. Okay, good. Okay, anybody? Mana nak buat? Okay, Ikhwan. Apa nak macam mana? What, give me some information. Tak ada? Okay, Nur Ain. Nur Ain Hanisa. Macam mana?
I'm not sure, sir.
Not sure. Give me one function first. Give me one function. What is the area under what curve?
Under GX.
Area under G of X. All right. So that is the first thing. Area under G of X from where to where?
From 0 to B.
From 0 to B. Okay. So that is the first thing. That is the first idea. That's good. So it's area under G from 0 to B. But the area under G from 0 to B is the whole thing. We don't want the whole thing. We only want what? That portion. Okay. So what area do I have to take out? Just look at the graph. Nur Syahira. What area do you have to take out? Nur Ain tu dah mention satu benda dah. Very good. Okay, so what area you have to take out? Sebab area under D, alright, is the whole thing here. You have to make the adjustment. Okay, one Najihah. Tengok graph dia. What area do we need to take out? Nur Ain, maybe you have the idea now. What area do you have to take out?
Area A.
Area A. You have to take out not the area A. It's close. No, area A, area mana? It's not area A. If you take out the area A, then you take out everything. Okay, so forget about A. Now we are looking at the area under G, which is already we know. Then you have to take out that part that will. Apa yang part tu? Area under apa tu? Area mana tu?
Area of rectangle.
Area of the rectangle. Okay, we don't want the area of the rectangle, huh? All right. You observe that is the rectangle. Okay. Now, how do you get area of a rectangle? Area of a rectangle, you know already the value of x. Okay, which is 0 to b. That means b. Now, in order for you to find the area of the rectangle, what else do you need?
The length of y, sir.
The length of the y. So I need that point. So for x equal to b, I want to find the value of the y, call it y1. Okay, or you can call it another point, ABC, call it b. Okay, so given you got b, I can find y1 because intersection here. So I know y1 or d, then you can find the rectangle. Rectangle is simply equal to what? Equal to the value of the x multiplied by the value of the y. Okay, width times length, or width times height times length, width times length. So b multiplied by d. So that is the area of the rectangle. So you have to take out. Right? So what is the area C? The area C is the following. The area C is the integral from 0 to b of g of x dx. Is it d or is it f? Yeah, g. Okay, from 0 to b, and then you have to take out the rectangle. Rectangle is b multiplied by d, or you can use b multiplied by y1. Okay. Now, I can do that in terms of integration. So now I do it in terms of integration, will be like this. The integral from 0 to b of g of x minus the integral from 0 to b will be the same thing, okay? Will be the rectangle from the area under y1 from 0 to b dx. So y1 is the constant function. Y is equal to d or y1. You can use d or you can use y1. That is the horizontal line, okay, which is a function. So you integrate the horizontal line, you get the rectangle, okay? But in terms of definite integral, it's the area under what? Under d of x from 0 to b. You take out the area under the horizontal line, okay, which is y1, where you can get already from x equal to b. The area under the horizontal line, y1, and that will give us the rectangle. So you take out the rectangle, I get area C. Okay. All right. Any question? Good. There? Okay, so that is area C. Now, there are a few more areas which we can manipulate from here. So I will continue from there, next class on Wednesday. And then, we will look at application. So hopefully on Wednesday, I can finish this part here, and then the application, so that by next week, we can look at the last topic, the derivative. All right, okay. Okay, good. I think our time's up. So I will see you again. Have a nice day. Do the questions. Stay home. Take care. I will see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Alright.
sir.
warahmatullahi wabarakatuh.
Okay, thank you.
Thank you.